Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Umar Irfan bin Nik Arif Hasni with metric number 63521. My supervisor is Dr. Johari bin Abdullah and welcome to my final year project presentation. So today I will present my final year project with the title SEED. For today's presentation, we will look deeply in 8 significant points for the SEEDS project. We will start with the introduction and end with the presentation with the FAQ sections for this project. So allow me to begin my presentation with the first point, which is the introduction. Why do we need this project and how important is this project? Let me introduce you first. What is SEED? SEED is an acronym that stands for Student Emotion Detection System. As the name proposes, the system can be used to detect the student emotion during the class sessions. How does SEED do that? SEED utilizes one of the mechanisms in artificial intelligence, which is deep learning. It makes it possible to detect the student emotion during the class sessions. Generally, we have many essential aspects in our life, such as health, family, luxury, and so on. Education is also one of the vital elements of our life. Education can bring us closer to all those essential life aspects. In Malaysia, most of people will spend the average 70 years for education. They will start as early as 5 years old at kindergarten to prepare the children for the primary school. Students will spend almost 6 years at primary school, struggling, studying, and taking the exam to enter the secondary schools. After that, students need to study for 5 years before finishing the school education level. A higher education is the next level of education. Most people would take about 3 to 5 years of study. This little story shows us how important is education to people, or at least to most of us. Students can choose what level they want to take at the higher education, but everyone will start with the diploma or equivalent level. The highest level of education is the Doctor of Philosophy, or known as PhD. At university, the conventional way of teaching and lecturing are basically by face-to-face interaction. This method will require the lecturer to stand in front of the classroom and deliver the lecture based on the syllabus that was already set by the universities. A student in the class must listen, take a note, and focus on what the lecturers teach. Attention is the most crucial part, and without it, the class session is pretty much useless to students. Some of lecturer may give a short exercise, simple quiz, activities, or any feedback forms to test and know how much student can understand from their classes. This is the conventional way of teaching, and the most important question is how effective is that was. Without knowing the actual student understanding or response to the specific course, it is impossible to pinpoint the student's understanding. This is very important, especially when the lecturer teach the specific course generation by generation without knowing if the student understand the course. With this comes my second point, which is the problem statement. In this section, I will tell you what things that inspire SEEDS. As my point earlier, the current education system is lecturing in front of many students. Depending on the student amount, it is physically impossible for the lecturer to tell how effective their class is. A few problem statements arise and waiting to be solved, which is, first, how to visualize and tell the real classroom without any ambiguity. Second is how many students pay attention to the lectures and what is the average of it. Last question is, what is the real performance for the current, past, or even future class sessions? All those critical questions cannot be solved by manually guessing and estimating. To have the accuracy, we need data, a real-time data from the lecture session that will be collected from time to time. With that, we can put a conclusion and accurate answers to those questions. For the next point is, what will SEEDS achieve? What is the main and side objective for this project? The main objective is to aid the lecturer. SEEDS will be developed as a device, system, and mechanism to improve the teaching method with the emotion data from time to time. Another side objective for SEED is to solve the problem statement earlier by telling the lecture status and effectiveness rate of the class sessions. With data visualization, it is possible for lecturer to know how effective the class is. Lecturer also able to know the average number of students that pay attention to the class. The numbers and figures are essential for the lecturer. Lastly is, of course, by giving the class summary to the lecturer and tell them how the class is going on today. Next is the SEEDS scope. What do SEEDS cover and what does it not? First is the audience. Who as the test group is, SEEDS will be conducted in the UNIMAS area. preferably at the Classroom. So the test group or audience for SEED is only the UNIMA student ranging from 90 years old and above. Time in here is how SEED execute the emotion detection. SEED will calculate the emotion in a specific time interval that will be set from the system. The best time interval is still unknown, as it should be run and tested iteratively until we got the best result. For the test case, SEED will start with detecting student emotion for every 20 seconds. For every 20 seconds, SEED will capture one frame and analyze the emotion percentage from that. SEED's implementation will be covering Android mobile apps and a website for system administrator. SEED will not be covering iOS operating system due to simplicity and cost constraints. SEED's detection session will be done during lecture hours only. It needs to detect the emotion during lecture sessions. Because of that, it will not operate outside lecture hours. Lecture hours at UNIMAS could be as early as 8 a.m. and as late as 10 p.m. from Monday to Friday. Let us look at some of the existing system at the background study sections. First is Emotion Recognition in e-Learning System. This system utilizes OpenCV and Convolutional Neural Network, as known as CNN. It then will translate the 2D output to 1D vector, and finally, the system will be classified into the fully connected network. The system has 3 steps to operate. First, it will identify the face and crop it to the specific size. This will require OpenCV to detect and cropping the face into a standard image format resolution. Then the features extraction begins. CNN layer will do the feature extraction process. Finally, a facial expression will be processed using a fully connected network. Second system is Student Emotion Recognition System. The system relies heavily on the eye detection region module. It is also utilized a Viola-Jones algorithm and local binary pattern as a face detection framework. The system works by, first, it will take the input in a video format, extract it, and process multiple frames in the video. Then later, it will start to detect the visibility of the eye region and the head movement. Lastly, the report will be generated in a graph plotted by the visibility of the eye and the head's movement. Third system are OpenFace. This system is an open source system which is available for download at GitHub. Generally, this system utilizes a point distribution model to capture the landmark shapes variation. After that, a patch experts then capture local appearance variation of each landmark. OpenFace also displays an action unit that is used to detect all emotion percentage in real time. The intensity and presence module for action unit will be based on the linear kernel support vector machine and regressions. Linear kernel support vector machine will handle the action unit presence predictions, and linear kernel support vector regression will detect the action unit intensity. And lastly, for our comparison is the commercial software which is called FaceReader. The Knowledge Information Technology company developed FaceReader, and it able to detect up to 7 basic emotions. It also makes it possible to put the custom expression in the system, which is fantastic. FaceReader also detects the emotion in a real-time environment by using the webcam and detecting the emotion using offline mode, which is based on the video or image uploading. Lastly, here is our summarization for comparing those system features with SEEDs. They all look great, but basically even the greatest system could have flaws in it. As a developer, it's our duty to fix those flaws. Basically, in this table, SEEDs will include facial detection, data visualization, emotion detection, export reports, web platform, mobile application, crowd detection, and of course with no subscription fee. Our next one is methodology. Here is all the methodology that you use to develop SEEDs. The methodology is how and what we use to develop SEEDs. First, we start with mobile application development. I use Firebase for the application database. In here, it will store all lecture emotion data, and lecture can retrieve the data back within the app. Second is Flutter. Flutter is the mobile application system development kit (SDK) that was introduced by Google in 2017. It has a powerful function and has been selected for this project due to its stunning interface design. And that is TensorFlow, which is a software library for deep learning training. For SEEDs, it will utilize the TensorFlow Lite for the mobile application use. TensorFlow will be trained with FER 2013 dataset, which has more than 23,000 datasets available. This dataset will be trained using FCSIT mainframe due to the hardware capacity limit and constraint. For the website, here are 6 typical applications used to build it. First, we start with a normal trio language, which is HTML, CSS, and JavaScript. Next is we also use Bootstrap to ease our website interface development. SQLite and Apache will be used for backend communication and database purposes. Here is the general seats architecture. We utilize a smartphone and put it with a tripod for stability and angle accuracy. The emotion will be captured within the camera radius. The data will be displayed as soon as lecture finish detection. It also connects with a Wi-Fi or GSM connection to send the result to the Firebase. Here is seats flowchart. Lecturer will start the system at login page. The lecturer needs to have the account first, and this account only can be registered from the backend. After the lecturer has successfully logged in, lecturer needs to pick the class session to record. By clicking the start button, the system will start and analyze the emotions. Continuing from the last step, after lecturer press the start button, it will start reading the input video using OpenCV and then send it to the TensorFlow Emotion API. It will begin the emotion detection and stop when user hit the stop button. Before it start to detect the emotion, it basically will count how many students in each view range and take the average of that number to detect the emotions. After the lecturer hit the stop button, SEEDS will display the result of the emotion detection. Lecturer also able to generate the report from the system. For SEEDS scenario detection, we consider 3 scenarios, whereas the most ideal and that is predicted to have the highest accuracy is the auditorium type seating. This can be found at TMM, which is also the main reason we select TMM for our ideal case detection placement. For the other two, we have a typical classroom and a computer classroom. We predict that it will have standard accuracy for the regular classroom because certain student face cannot be detected when they sit in a straight lines. The last one is the computer classroom, which usually used for the lab sessions. For this type of classroom, we predict that it has the lowest accuracy due to the face was blocked by the computer. The smartphone placement needs to hang up and pointed down to the student to cope with these two situations. Next is we will have the context diagram. A context diagram is our level 0 DFD. It depicts the higher level of the system interaction with the external entities. From here, we can see SEEDS has 2 users, which is lecturer and system administrator. The lecturer can control the system using the start and stop button and send the class session data. The system can reply the emotion data generated in report, view report, and data search to the lecturer. For the system administrator, it can have access to the systems or devices. Then the system will reply with the class emotion data to the system administrator due to the request. Our last methodology is ERD, or known as Entity Relationship Diagram. ERD is a visualization of how the database will communicate. In here, we can see we have 3 tables that are used for this project. We have the class performance table for storing all emotion session detection, the class session table that is used for the class schedule or lecturer's class session, and lastly is the lecture table that is used to store necessary lecture data for the login access. Our next point is on the wireframe. Here, I will show you how SEEDS will look for both lecturer and system administrator. A lecturer will use the smartphone apps, and the system administrator will use the website to manage the back-end system. The lecturer will start at the login screen page, and after successful login to the system with time register credential, the lecturer will eventually arrive at the landing page. As we can see from the top of the screen, it shows the logout button for lecturer to log out. A welcome text will be displayed the full lecture name, which it will retrieve from the backend. At the center of the screen, we can see the current class sessions. The lecturer can hit the stop button to stop the recording session. Lastly, at the bottom part, we can see the class schedule for lecture. These classes will be sorted out based on the day and will be marked with 3 different markers that indicate red for past class, green for current class, and orange for the next class. When lecturer hit the start button, it will bring to the emotion detection page. The lecturer can see the current emotion detection and it will be displayed along with the recent detection time. At the right screen, it will display past emotion that was already detected. A lecturer can hit the stop button to stop recording. The result page will be displayed once lecturer hit the stop button. From the top, we can see a display current class name and the schedule time for the class sessions. Then at the display data, we can see first is the total class performance data. This will indicate overall performance for the class session. Going downwards, we can see the total average of the emotion detected. After that, we can also see the total of student and the average student, which is half of the student number. This is the amount of face detection. The actual start and finish time will be displayed using the timeline down here. It will display the actual time that lecturer start the class and when it finished the class. And lastly, it also shows how many times SEEDS capture the emotion along with the detection time interval. Next is for system administrator. Here we can see the usual login page designed in a gray-black gradient, fit in with blue-red gradient login button. The website was designed with a black theme to ease the system administrator eye. When system administrator log into the system, they can see the dashboard displaying the total registered lecture and total registered cost for the system. At the left side, it has a menu panel which can be used by the system administrator to navigate through each page. The first icon is for the lecture page. When the system administrator hit the icon, it will bring them to the registered lecture list with a pagination display. They can hit the new button to create a new lecture and it will bring to the next slide. The next page is the Add New Lecture page. System admin can add lecture and enter the full name, password, and courses for the lecture. After it's done, they can hit the Save button and it will bring them to the View Lecture Information page. It will display all the information entered earlier. They can hit back to display the lecture list again. The third icon is used for the course page. Nothing much different compared to lecture view. It's all the same interface design. When system admin hits the new button, it also brings the new course page. Here, system admins can type the name and pick the class session for the course. They also can assign which lecture to teach the course. When they hit the Save button, it will go to the Display Information page, which will display back all the data entered before. In this page, it will display all the information entered earlier. They can hit back to go to the first course page that displays the course list. Lastly, I will answer the most frequently asked question, or in my case, possible question for SEEDS project. First question are, what platform that SEEDS will cover? The answer is only Android platform for the mobile operating system, and for the website, it shall cover the major operating system for desktop. Here is one thing about mobile application. Because we use Flutter SDK, and Flutter is one of the hybrid mobile development technique. With this development, it is possible to make one code base that can run on two different platforms. But for SEEDS, it will only be tested for Android platforms due to the cost constraint. Since I only have the Android phone, it is easy for me to use the functionality and do the interface testing on Android devices rather than iOS devices. The second question is what SEEDS detection interval is. The answer is with some predefined intervals. For initial testing, we will use 20 seconds gap before detecting the emotion. The best interval is we need to do trial and error phase and decide which is the best interval to be used on the SEEDS platforms. The third is how do SEEDS store data. For the recording, it will store temporarily and delete it after each recording session finish. This also makes SEEDS doesn't need student consent due to record their video. For the emotion data, SEEDS will utilize a cloud storage to store all the data. 4 is what SEEDS operation time. During lecture hours, as SEEDS need to detect the student emotion during a class sessions, the lecture hours in UNIMAS are as early as 8 AM and up to 10 PM from Monday to Friday. 5th, does the age affect SEEDS accuracy? Here is one thing about age. Our emotion does not affect by age. For instance, if a baby happy and an adult happy, they still smiling, which indicates their happiness. Same goes to the system, as it only detects the emotion, so age will not affect SEEDS accuracy. But in the case of face recognition, yes, it will affect. We need a specialized data set for that. SEEDS target group is UNIMAS student that is ranging from 19 years old and above. And that is our last FAQ section, which indicates the end of this presentation. Next slide is just the list of references that I use for this slide. And that is all for my FYP presentation with title SEEDS. If any question, do contact me using the number provided. Thank you for lending your ears. Have a nice day and Assalamualaikum.